We are Study Sprout.
Hi all students, I'm going to start my channel. So my channel name is Study Sprout. So this time I'm focusing only grade 10 children. So I'm going to teach math and science. So I will start real number first. So I knew that you already learned from school and then some institute and other resources and all. Then you know what is about the real numbers and all the concept. Everything is clear. But I'm going to show you some previous question paper questions and some important questions and all. Okay. So I'm going to teach you what is real numbers. Real number means it's a set of rational numbers and irrational numbers. But so then you're going to ask you what is rational number and what is irrational number. Yeah, so you should know that what is rational number. So what is rational number? Numbers that can be expressed in the form of P by Q form. So that means it's like in a fraction form. So P and Q are integers. So what is integers? You already know what is integers. And Q not equal to 0. So that means your denominator should not be 0. Okay? We'll go for some examples. So first example is fraction. Any fraction where both the numerator P and denominator Q are integers and denominator is not 0. So for example, we can say 1 by 2, minus 3 by 4, 5 by 6 and all. So why we are saying that 1 by 2 and minus 3 by 4 and 5 by 6 is a rational number? Because 1 by 2 we can say that 0.5 and this is a terminating number. And minus 3, 4 by 4 also is terminating number. And 5 by 6 is also a terminating number. So we'll see that more examples for the rational number. So these are the things. So I'm going to show you another example of rational numbers. Okay. So hope you understand this part. What is real numbers, and the real number can be divided into brackets including rational, irrational. So I'm showing the rational number and then some examples also. But I'm going to show you in other examples. Okay. Okay. Next example, integers. So we can say integers actually it's a positive, negative or 0. So why integers are rational number? We can say the example 5 can written as 5 by 1. So that means a P by Q form. It's a 5. And then minus 2. If you take integer minus 2, then you can say that minus 2 by 1. If you can take 0 is also a rational number. Why? Because 0 by 1. Okay, 0 by 1 is a P by Q form. Okay, so next example is terminating decimal. Terminating decimal is also the same, that it's a irrational number. So we can say how or why we are saying that is a terminating decimal is a rational number. So that decimal that end like 0.25. So I will show you 0.25 we will write because of the decimal. So we can divide with 100, right? Because this is it. How many place you going to make a decimal? Because of ones. So this is it. You can divide it by 100. So 25 by 100 is a 0.25. You already know, it's a lower class, you already learned how to convert decimal to fraction. So 10th 100. So 25 by 100, you can say that it's a 1 by 4. So 1 by 4, you will say that is a 0.525. So it's terminated. So we will say that 0.25 is a rational number. Okay. So you can check out more numbers, then you will understand So which decimals are going to be a rational number. So I'm going to show you the next one. Next type of rational number is repeating decimals. So repeating decimal, that is also another example. Repeating decimals. So we will see what is, I will show you some example that why we are going to say that repeating decimal is also a rational number. For example, we will say 0.333, etc. So the 3 is going to be repeated. See, the one digit is repeated. So we will consider that is a rational number. So what's the number? Like a 1 by 3. Check out another one, like a 1 by 7. So we will see 1 divided by 7 is also a rational number. Why? Because 1 divided by 7, I'm going to divide it, okay? First one, how many 7 in 1? 0 point, and then you're going to put a 0 here. So now your number is 10. How many 7 in 10? So that is 1, then 7, then your remainder is 3, and then again put 0 here, so then here, then 4, 28, then again you will get a remainder 2, and then you put 0 here, then 2, 14, then again 6, again put 0, then 0 here, then how many? 8, then 56 is going to be a 4, and then 0 again. How many 7 in this is going to be in 5 is 35, again 5, then put 0. How many 7? That is going to be 6. 7s are 42, 7 sevens are 49, then 1. So it's going to be repeating again 1. So the set of number is going to repeat it. So here we can say 0.142857. This number is going to repeating again. So that type of number is also a rational number. Okay? Eliminated, or if the number is not repeating, we will say that is a irrational number. For example, I'll show you. You already know that this value, you already heard this value, it's a pi value. Is also the example of irrational number. What is the pi value? Is 3.14. It's etc. It's going it's not ending. Next one, we will say that square root. Like the sum root 2, root 3. It's not a perfect square. So if it is not a perfect square, that is also a irrational number. Also numbers with non-repeating and non-terminating. For example, I'll show you. The example we can say 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be, see, the number is not ending, it's going through it. So that type of number is also a irrational number. Okay? So we will go and see the next one. This is actually the basic concept. It's a very, very basic concept of real numbers. But in real number chapter, we have one formula, that is how do you find HCF and LCM. You already know what is HCF, you already know what is LCM, and also one more term is also there, it's a prime factorization. So I'm going to show you that concept, then we'll start some previous year question paper. Okay? So guys, this is the last concept about real number chapter. So we go for the prime factorization. These two sections actually it's very important. So one is prime factorization model and the next is HCF and LCM relationship. These two are very important. You are focusing more about these two sections. So prime factorization means expressing a composite number. What is composite number? More than two factors. And what is prime number? That is the number 1 and number itself. For example, 2, 3, 5, 7. These are the numbers. There is no more than one factor. That means a number and number itself. That means if you take a 3, example, the 3 have only one number, one factor and the 3. You can't get any other factor. Composite means if you take a 4, you can see that is 1 is a factor, 2 is a factor and 4 is also the factor. So you can see the 3 factors there. So that's the difference between the composite and prime numbers. Okay. So we are going to look for some composite number prime factorization method. Okay, that is the one thing. And the next thing is HCF and LCM relationship. Higher common factor and least common multiple. This is the full name of these two. And then we are going to use some formula in this chapter, that is HCF of two positive integers into LCM of two positive integers equal the product of two positive integers. This is very important. You have to make, this is very, very important. One tips I am going to give you. You have to make a formula book, start from now, so that is going to be very useful when you're going to do some work, like when you're going to do some problems and all. Okay, so that's going to be helpful, and sometime you can revise it, some formula that is very good for you in your future. So the first formula is HCF of AB into LCM of AB equal that A cross B. AB means two positive integers. That's it. So then next video I'm going to show you some previous year question paper about for real numbers. Okay, that's it. So guys, can you please subscribe my channel? So you will get all the videos, you will get some examples, some previous year question papers. So that's it.
We are Study Sprout.